Hello my friend, happy to see you here. Today we have quick, tricky and relaxing algebra question. We have k times k times k equal to k plus k plus k. And we need to solve this question for k, so if you have your solution, your answer, you can also write it in the comments below and then we will check our answer, so it will be really interesting. So a lot of students might be thinking, okay, maybe k equal to 0 is a solution, is a root to this question, so just look at it. So for example, we think that right now we're thinking that k equal to 0 is a root to our question, because a lot of students might be thinking that this is the best, the fastest way to solve this question, because 0 times 0 times 0 equal to 0 plus 0 and plus 0, which is absolutely correct. And a lot of students might be thinking that this is only one root. But in terms of algebra, we need to simplify it, we need to factor something, we need to write something on the left side, on the right side, we need to mix everything to find maybe we have another roots. So that's why just we say, okay, we have k equal to 0 is like our first root, but we need to solve it for for another root. Sorry. So right now let's multiply k times k times k equal to k cube. Okay, everyone knows about it. So k cube right here equal to k plus k plus k equal to 3k. And right now let's look at this question from a different angle, because everyone knows about fundamental theorem of algebra. K cube, it means 3 roots in total. We don't know how many real number roots, how many complex roots, but right here we can find maybe not like maybe a k second or k third. So that's why we just write this 3k on the left side. So k cube minus 3k and equal to 0. Right now, the best way to solve it is to factor our k. Let's do it. So k, and in parentheses we have k square minus 3. K square minus 3 equal to 0. And right now, one really interesting and very tricky moment, because a product of two expressions equal to 0 when the first expression equal to 0, so k first is equal to 0, and the second expression equal to 0, so k square minus 3 is equal to 0. And right now we can easily see, okay, we had it before, we solved it, we have our k first equal to 0, so everything is great, our root is absolutely correct. But right now we have another thing, we have k square minus 3 equal to 0. So let's solve this equation. Let's solve for another root. So k square minus 3 is equal to 0. So there are a lot of ways how can we solve this question. Maybe the best one is to express it as a difference of squares. So let's do it. So we have k square minus, instead of 3, let's write square root of 3. Let's write square equal to 0. So right now we considered it as a difference of squares. This is, for example, our a, and this is our b, and a square minus b square equal to a minus b, a plus b, a minus b, a plus b, a plus b. And right now, let's simplify it. Let's factor it. We have k minus square root of 3 and times k plus square root of 3 equal to 0. So a product of two parentheses equal to 0 when the first parenthesis equal to 0. So k minus square root of 3 is equal to 0. Right here in this case, we're talking about k second, and k third plus square root of 3 equal to 0. And from here we have k second equal to square root of 3. This is our k second. This is our second real number root. I want to underline that this is our real number root. And k third equal to minus square root of 3. So this is our third root. So right now we can easily say that this is our full solution to this question, because right here in the beginning we had k cube. So it means that we have 3 roots in total, and we already found it. So we have k first equal to 0, k second equal to square root of 3, and k third equal to minus square root of 3. And in the end, let's check these roots real quick. So first of all, I want to rewrite our question right here. So we have k times k times k equal to k plus k and plus k. So right now let's check, for example, for k equal to 0. So we already checked it. So k equal to 0, everything is great. 0 times 0 times 0 equal to 0 plus 0 and plus 0. Everything is great. Right now let's check real quick our this root. So we have k first. Right here we have k second equal to square root of 3. So we have square root of 3 times square root of 3 times square root of 3 equal to square root of 3 plus square root of 3 and plus square root of 3. Okay, so right now let's learn, let's remember great algebra tricks. So square root of 3 times square root of 3 equal to 3. So as a result, on the left side we have 3, and this one we leave it without any changes. So 3 is square root of 3. What about this one? How can we add it? So for example, my quick trick right here. So for example, square root of 3 is our a. The next thing, we have the same a and the same a right here. So when we add a plus a plus a, we have 3a. And in our case, a is 3 square root of 3. So we have 3 square root of 3. So we have equal to 3 square root of 3. So everything is great. Our second root is also great. Right now, the third one, so k third, equal to minus square root of 3, because sometimes happen that maybe a root is not good, okay, and we need to reject it. So let's check it. So we have minus square root of 3 times minus square root of 3 times minus square root of 3 equal to minus square root of 3 plus minus square root of 3 and plus minus square root of 3. Okay, a few thoughts about this question. First of all, right here we have an odd power of expression, so it's not like minus times minus. We have minus times minus plus, and plus times minus equal to minus. So I'm talking about simple word because, you know, I don't want to get too much like complicated right here. So we have an odd power, so it means that the negative sign, negative, right here square root of 3 times square root of 3 equal to 3, so we have negative 3 square root of 3. What about right here? So we have, as I said before, this is our a, this is our a, and this is also our a. So we have 3a. Okay, and as a result we have minus 3 square root of 3. So we have a completely correct answer. So right now let's write our answer, and in the end I want to show you this question from a different perspective. So just look at it. So this is like a special case because a lot of students, maybe like 90% of students, they like algebraic expressions, but maybe 10 or 20% of students, they like to check a solution by a geometrical expression. So we have k cubed equal to 3k. Okay, and if you see this type of expressions, I really hope you understand that we can express these graphs right here on this plot. So I want to do this like very small thing right here. So k cubed, everyone knows that this is our this line. I want to do this approximately. Yeah? I want to do this approximately. And secondly, 3k, this is our linear function. So basically this graph can easily intersect with our k cube in 3 points. Right here we have minus square root of 3, right here we have 0, and right here we have square root of 3. Okay, so basically you can see this from this angle. So it's not only one root, but 3 roots. And in the end, my maybe the quick tip, which can easily help you on your exam. For example, if you have this, my last hint right here, so k cube equal to 3k. So right now let's talk about, for example, k square, for example, equal to 3. So everyone knows about, for example, this expression, k square equal to 3. This is like a quadratic equation, but without a second coefficient, but k square equal to 3. And right now ask yourself, what about roots? How many roots do we get from here? Of course, we can get 2 roots. Moreover, I can write it like equal to 3k plus 2. This is a quadratic equation, something like that. And as a result, we can get from here, we can get 2 roots, okay? Discriminant, you know, a basic thing. But what about k cubed equal to 3k? So according to a fundamental theorem of algebra, when we have k cubed, we are talking about three roots in total. And exactly in this case, we don't know how many real number roots, how many complex roots right here. We don't know exactly about this thing, but this is extremely helpful because a lot of students might be sitting on an exam and they might be saying, okay, k equal to 0, this is only one root. But if we have 3, so it's not that easy, okay, because we are talking about 3 roots and 3 roots in total. Okay, so a few thoughts about this question. This question is easy. I'm not going to talk anymore because this question is really easy. You can solve this question in a few minutes without any problems. But I want to say you this really important thing, like geometrical perspective, this algebraic perspective according to a fundamental theorem of algebra, this quick check, because sometimes happen that our left side is not equal to right side. You know, few thoughts about it. But the main thing is this solution. So I really hope you understand it. I really hope you know what I mean right now, because maybe a lot of teachers, a lot of students here, and that's why I want to mention, I want to underline really important moment. For example, for students, they might be saying k equal to 0 is only one solution, but as you can see with this solution, with this factoring, we find our two roots, which is also really good. So I want to thank everyone for watching. Thank you for being here. I really hope you understand it. This is not that hard. This question is not that hard. So I really hope everyone understands what I mean right now. And thank you for watching. See you in the next videos. Also, I want to say I'm glad to see you here, and I'm really happy that we have this type of community, a lot of teachers, a lot of students here, so it's also really appreciated if you leave your comment, leave your response, and we discuss a different thing. Also write your question, what you want to see on my YouTube channel. It's also really great and really kind of you if you write your questions, your Olympiad question. It's also really great. So thank you everyone for your time. Take care of yourself. Have a great day. See you in the next videos.